BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers for making 2018 a success.
Good morning, everybody. So we're going to kick off here today the post-lunch track, which is always the best one to be. Try to keep you guys invigorated and awake here today. So the talk you're in today is Unraveling the Threat of Chrome-based Malware, talking about malware in your browser. We're going to talk about a little bit of a war story we have and dive in. My name is Justin Warner. I'm a principal security engineer with Gigamon. Formerly spent some time in the military working for the US Air Force doing counterintelligence work. Spent 3 years breaking into places, which really shaped my view a lot of threat operations. Having to actually go do it, learn about the perspective they get, was very valuable. There I worked with Various Group's Adaptive Threat Division, and then a natural break occurred which led me to work with ICEBRG, which became Gigamon. I like to be a little bit more human, so I'm not just a work robot. I have a hacker wife, so married into the hacker community. Some people hate it, some people love it. I personally enjoy it a lot. I have a young daughter, she's 2 years old, and I do a lot of volunteer work in disaster response and relief stuff. Tons of fun, ways to get away from the computer and enjoy the day.
Hi, everyone. My name is Spencer Walden. I'm a security engineer at Gigamon ATR as well. I graduated from the University of Washington, Seattle, other Washington, a year and a half ago. I've been at ICEBRG/Gigamon for 2.5 years now. And while I was at UW, I also did undergraduate research where I actually worked on a Chrome extension project that was super cool. It's discontinued now, but you should check it out. It's a really cool project. And yeah, I'm really interested in like malware and the different methods that adversaries use to communicate, and then covertly, and then working to detect those types of things. It's fun, the whole cat and mouse game going on there. So moving into this. Who here has used a Chrome extension? All right, this is relevant. Who here has developed a Chrome extension or worked to develop one? Okay, less people, but cool. So this is going to be new for some of you. It's pretty simple. I just ripped this straight from Google's documentation, which is really good. Super straightforward to make an extension. Basically, it's just like a web page. It's just some HTML, CSS, JavaScript, images, whatever you need, thrown into a folder. You have the exact same things that you can do with a web page, including XML HTTP requests, which are basically web requests you can make from JavaScript. The interesting thing here is that unlike working in a web page, Chrome extension will actually have access to Chrome APIs. That way you can actually extend browser functionality such as bookmarks and tabs and lots of other fun stuff. What does it look like? Yep, here's a folder of an example Chrome extension. Basically just any kind of normal website kind of feel to it. You can structure it however you want to. The important thing here is that you need a manifest file, which is a very specific formatted JSON file. And it basically just specifies kind of how your extension is supposed to fit together. How do all these elements work together? So what does the manifest file actually have in it? Some of it's kind of not that relevant for our purposes. It's just kind of UI, UX, what's it look like in the browser? Does it have a pop-up? Does it open tabs? Blah, blah, blah. Metadata, what version is it? Who's the author? And then the meat of this is the permissions and what I call registration, which is basically you specify like a background script, and this will run at all times in the context of the browser, or the content scripts, which you basically allow to inject into different web pages based on a certain set of conditions. And registration also might cover, or I consider to cover like things like the content security policy, and then the permissions are basically the different Chrome APIs you want to interact with. You have to declare these. Some of them will actually prompt the user. You may have seen this, you know, blah, 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 can read and change all the data on the websites you visit. You know, kind of scary sounding, and it's meant to, because there's a lot of power you get with this. Some interesting permissions to call out that I found. There's this background permission you can set where the extension will actually come up with the system. So this image with Process Explorer is showing that Chrome is actually running because of an extension that has a background permission set. But you'll notice in the Windows taskbar, Chrome isn't actually open. There's no blue line there. So kind of an interesting thing. Right, so Google actually does review like all the extensions that go into their store. They have an automatic process, and that will kind of generate a score. That score will, if it's low enough, trigger like a manual review process. And they'll actually do takedowns on different extensions if they don't, if they're not up to snuff, right? One example was uBlock Origin. It was taken down for obfuscation in 2015. Kinda, the developer made a big stink about it. But yeah, so with working with their team, when we found all this malware, they were super supportive, and it was really good working with them to get stuff cleaned up. Yeah, so how often, when you use your computer, how often do you have the browser open? 100% of the time? Yeah. Browsers are running like on pretty much every system all the time. Like in Seattle, we've got the light rail, and that's got like TV screens showing, you know, the schedule of the light rail trains. Sometimes it crashes, and you know, you get that oh snap like Chrome notification in the page, and so I mean it's running on all kinds of different systems, and so it's really powerful, right? Like to get a plugin into one of these things. And one of the cool but kind of bad maybe things is that the web extension API, which is being pioneered by Chrome, is being adopted into the different browsers. So Edge, Chrome, all the major ones, or except for Safari for some reason, are adopting this framework. So if you write a malicious Chrome extension, you could potentially just easily port it over to the different browsers, which could be cool.
So what led us here today? What got us, we're a network security company, what got us on this rant and soapbox of Chrome extensions? Frankly, the reason it got us there is because we saw it used in the wild. And so we, while monitoring customer environment, like to say that something sexy happened and we had this magic analytic that found all evil, but it simply wasn't the case. We had an analyst going through network traffic, noticed something suspicious, which is how 90% of things are found, and kind of started pulling on that thread. What they essentially discovered was that there was a ton of HTTP traffic to really funny looking domains, and the HTTP traffic was coming from a Chrome extension. You can see that via the origin header and the PCAP snapshot on the bottom right. Essentially, they could see exactly what extension that was coming from. They continued to unravel that thread and discovered an extension that was prevalent across massive customer sets, massive infrastructure involved. And the follow-on investigation essentially led to this extension with over 500,000 victims and what was led to be a suspected fraud campaign where they were browsing pivot traffic through the Chrome extensions. So we're going to detail this a little bit more in depth now. I like to take a pause and say, as a red teamer for 3 years, I was horrible at phishing, and I stressed out every time I had to send a phishing message. And I always thought social engineering was very difficult from a computer perspective. Breaking into physical places, easy. Sitting behind an email, not so hard, or not so easy. These guys, they simply named their extension Nugle, which was essentially, they would replace every Google logo with a Nyan cat. That was the whole purpose of the extension, and they got 500,000 downloads. Like, I was doing it all wrong as a red teamer all those years. And the funny thing is when we started doing a little bit of OSINT on this stuff, like tons of computer forums where people are talking about installing on their little brother's computers for trolling and putting it on work computers because it was funny to see their coworker freak out. Like, it turns out this is all malware that these people are running around and installing. So how did this extension exactly work? This is kind of the beauty of what they were doing. The actual extension contained no malicious code. So the extension was nothing more than a fully functioning, purposeful extension. In this case, replace the Google logo with Nyancat. But then, on a certain time interval, the extension would phone out for updates. It was the guise that they had set up. The updates, even more clever, was not just a straight, like, it was very hidden. In this case, if you look at the code on the bottom left, they were looking like they were downloading JSON updates, like maybe a configuration update. The function used was the AJAX call for get JSON. Little known fact that we discovered while looking at this, if you just append JavaScript string to your JSON blob, get JSON will actually evaluate it, assuming the unsafe eval permission is set in the extension. Who knew that? No hands for the computer. And so, yes, you can essentially just append JavaScript to a JSON blob and get JSON will execute that for you. So a very clever staging mechanism that would get used. We actually saw this evolve over time. There's one other one I wanted to call out is that they also modified the jQuery library in some cases. So they wouldn't even have like a suspicious get JSON. It would just be normal AJAX calls. And then in the jQuery library, they had minified like their secret little stager to change behavior when they saw certain content inside of it. Very clever and very hidden, hard to detect given all the jQuery like versions that are out there anyways, unless you have a magic whitelist of every jQuery library you're tracking. So after they would stage the extension, they would essentially stage malicious code that led to a WebSocket getting stood up. So they would stage down some JavaScript, that JavaScript would stand up in a WebSocket, and that WebSocket would communicate with this full JavaScript rat inside the browser's memory. That JavaScript web tunnel was then used to pass back and forth JSON taskings. So essentially malware C2. It would task the browser extension agent to do things. Specifically in this case, it would task it to do click fraud. And so they would essentially pass a website, the browser extension would visit the website from the victim computer, and so on, just continuously. Some really interesting pieces of this is that we sandboxed tons of these and monitored them. They were not injecting every user that installed this extension. They actually throttled who they injected based on what we believe to be time zones, geography, and then volume. Like they would only inject a certain number of people at a time. And we believe that was likely like low confidence assertion that it was likely trying to minimize the chance of getting caught. Like minimize the times we're doing this, don't make it as obvious. So the traffic that we saw essentially when we were monitoring this and decrypting this traffic was almost exclusively advertising traffic. And it would come fast. Like when they would trigger and turn it on, depending on where you're at, it would go for hours. And talking more than a request a second for hours. If you can do the quick math, if you go out and price like how much you get for an ad click and an ad network, anything from it can go lower than 10 cents, it can go as high as $1. So like, click a second for 3 hours times, let's go low end, like a cent. You can make a ton of money doing this across 500,000 victims. Very profitable campaign. This started out with just 4 extensions. So we talked about Nugle. There were 3 other extensions, a bookmarks, a stickies, and a Chrome extension that was actually really interesting. Anyone who works in pen testing in here use an extension to change your HTTP request stuff to like add headers or, So change HTTP request header, that would be a really sweet one to hook an admin or hook a pen tester. This had 14,000 downloads, and if I had to guess, a lot of those were admins or some type of code developer. And that was actually a backdoor extension that was being used in this case. So we actually stopped there. We felt pretty good. We notified Google at this point, and then we continued to monitor. So we're a network security company. We weren't like really big into Chrome stuff, but out of due diligence, we continued to monitor this. And then last year, throughout the year, we noticed 35 more extensions go into the Chrome store. So there would be dev binges. We would see batches of extensions get uploaded that would continue this functionality, and another 153,000 victims over that year. We've continued to monitor this, and it's still very ongoing. We don't have any new stats to show you today. Essentially, this continues to happen. These guys are very persistent. So break glass if you find evil. This is the, for us, we very much, like as we started to scope the depth of this and how serious this was, we immediately reached out to Google. Again, we'll give more shouts out, like the Google team we worked with. Google's huge, I don't know everybody there, but the Google team we worked with was fantastic. They were very interested in what we had to say. They wanted to work with us. We have some tips, like what we learned in this interaction. So if you go Chrome hunting after this talk, here's some tips to share stuff with them. Share evidence. It's really easy to say I found something bad and send it to somebody. It's really hard for them to understand what you mean by bad and what got you to this step. In this case specifically, it was tough because they were doing that selective staging. So the Google team could go install all the same extensions we said were evil, and they may not get the JSON stager. And so they might be like, these guys are full of it. They don't know what you're talking about, like how do we trust them? So we provided, when we went through this, we provided full PCAP of all the sandboxing, everything we had, source code, write-ups, methodology, more or less a full-fledged report, and it was very appreciated. They were able to action it much quicker. Indicators are nice, like threat intel people, like IPs and domains are fantastic, the evil is fantastic, but methodology, how did we go about discovering, why did we stumble upon this, what kind of generic things were we looking for? It allowed them to go from solving the one problem we knew about to trying to evolve to solve future problems and continue to take down the class of attacks. Continuing on the list, I think the two biggest outcomes I'd like to highlight, in our case, we actually, there's two ways that Chrome extensions will get resolved. Removal from store, meaning people can't download it anymore. That doesn't mean it gets removed from computers. There's also a level of analysis that'll lead to them actually force removing and issuing like a kill request out to anyone who has it installed in their browser. So we actually, any of the extensions we've notified have gotten the kill request, but that's not true in all cases. It depends on the level of confidence and kind of severity of what they're looking at in the extension. Sweet.
Yeah, so great, like we found this whole malware campaign, how do we protect against it? So there's some IDS signatures that came out from the emerging threat set. I don't know if you guys are familiar with that. It's like Snort, Terracotta rules. So they're a little bit fragile. One of them's really good. It's looking for the actual WebSocket connection, like the JSON going back and forth once the tunnel is established. Fantastic. It gets it 100% of the time. And then the other one is actually looking for one very specific Chrome extension ID. So unless you have that specific Chrome extension, and you saw there was like 35 plus, it's not going to hit. And then with the WebSocket tunnel, it's only going to hit if the WebSocket tunnel actually gets set up, right? There is a lot of cases where this didn't actually get set up. So here's an ugly slide full of Terracotta rules. The first one is basically looking for the beaconing activity back and forth with the server before injection has happened. The second one is actually looking for the inject code, right? So this is the payload getting sent down on the update request when it decides to do this. And then this last one is after it's been injected on, they actually add a header to every request specifying the version of the payload that was injected on so that they could update the thing later on when it's beaconing. Some behavioral notes. So all of this activity was happening in one ASN. It was always an info or a pro TLD. Of course, there was Chrome in the user agent field because it's a Chrome extension. And then, yeah, a couple of other things just going on with the flows, looking for kind of interesting interactions between a Chrome extension and a weird server that you probably haven't seen on your network before. And here's some Yara. Yara's not really set up to work with JavaScript that well. It's more suited for binaries. But it's still a really nice kind of grep on steroids, where you can specify a bunch of different patterns and kind of what to look for and conditions, right? So like, I want this or this, and I want this and this. And so the first one I have looking for, because basically you can ID these extensions by looking for a couple of key things. The first one is looking for a manifest file that has the relevant permissions that are always set for this. They have to have web request and web request blocking, and then access to all URLs as permissions declared in the manifest file. So look for that. The second thing is looking for a jQuery library that's been modified. This was really hard to do. I do not recommend doing this, but yeah, a lot of hair tearing out making that one, but really cool. And then the third one is actually looking for the loop, the update beaconing code that is present in all of these. So if you get like a match on a Chrome extension with all three of these together, boom, you got it. Yeah, okay. So with Chrome extensions, I was looking at this stuff and I was like, hey, you know, there's a lot of timestamps here. Wouldn't it be cool to like map these out and see what kind of information we get out of that? So CRX files, which are like the Chrome extension files, they're basically just a wrapper on a zip file. And zip files actually have these file modification timestamps that get preserved when you zip up like a bunch of files. They are MS-DOS timestamps, and they don't have any kind of time zone information with it, so that's kind of annoying. And then there's the domain registrations. So we have, you know, who is records record when a domain was registered. We have all these domains associated with these Chrome extensions. Great, let's grab all those. And then also, this was really fun. So all the icons and the images that you used in these Chrome extensions, which did do what they were purported to do in addition to the malicious stuff, Adobe Photoshop was used to make most of these images, and they'll actually inject these XML payloads that have tons of timestamps in there of like, oh, they added a layer at this time, and they added a layer at this time, and really rich, and it's actually got the time zone information in it too. So that's really cool. Yeah, so actually graphing it out, you actually kind of notice something interesting here going on, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, from top to bottom. You'll notice that, so the orange corresponds to the PNG timestamps, the blue corresponds to the domain creation, and the green is the file modification from the zip files. You'll notice there's kind of a center going on Monday to Friday. I should also note, these are all normalized to UTC and based on the data set, because we had like about 2,000 of the PNG timestamps, unique ones, only about 100 of the domains, and like 700-ish of the file timestamps. But yeah, so kind of a Monday to Friday correlation. Here's by hours of the day, same normalization process. You'll notice kind of activity centers around 9 to 20 UTC. So this is really interesting. No hard, conclusions we can draw from this necessarily, but still really interesting, right? Yeah, so this is pretty cool. I was like, okay, so I have all these things. What does this all mean? So we took a baseline of like activity for like, because I'm kind of thinking, all right, like this kind of looks like a 9 to 5 schedule maybe, right? So what does this look like compared to an actual 9 to 5 schedule? So we're a networking company. We have a lot of customer data. So we take like a baseline activity curve for people working 9 to 5 in a time zone. We normalize that to UTC, and then we compare that with the different data sets that we have. So from left to right, you have the domain creation, file modification, and the PNG timestamps. And basically, we're looking for where it's closest to 0 is the closest match between like the baseline curve and the attacker curve. But yeah, so this actually kind of raised just more questions than actual answers. Because if you look back at this last graph, the far right one, it actually kind of corresponds to like a UTC shift of -1. but those ones actually had the time zone information included, which said +4. So since there was that discrepancy, it's like, okay, what's that telling us? Like, it kind of makes a lot of different narratives possible, right?
So being a red team guy, I'm naturally staring at this adversary making millions of dollars and wondering why I never did this exact technique for years. And so I kind of took a page out of their book and decided to go be evil for a while and satisfy that craving before coming back to blue. So what makes, like, stepping back at this, like, why was this adversary so brilliant to do it like this? Frankly, like, leveraging Google Chrome is a fantastic technique. In general, people trust the Chrome store, like, more than they trust a random exe downloaded from the internet or from a spear phishing email. Google wants open development, so people are inherently trusting like an open data and open development model. And I can bet you most people in here who all raise their hands saying they're using Chrome extensions aren't code reviewing every extension you download. Like maybe some, like maybe you geek out over that, but most times you're downloading a Chrome extension because you want quick utilities, and so that would defeat the whole quick piece of that. And so essentially people trust Google, Google trusts everyone, so people trust everyone. It's not exactly a great model. It gives you code execution in the browser, it gives you access to Google's APIs, everyone does all their work in Google, so you have access to everyone's work. So stepping back and kind of walking through the adversary lifecycle, I decided to research each piece of this. So if I was a bad guy, how would I start from ground zero and build a malicious Chrome capability? So looking at delivery and installation, there's a number of different ways that Chrome extensions can get installed inside of a user's browser. The simplest would be something like phishing with a link to the Chrome store. Maybe I just convince someone that there's some policy at their company, they need to come download the company's Chrome app, maybe I've guised it really well and made a beautiful lure, and convince them to come download it. They click on a link, there's nothing required to do this. You can get links to the Chrome store and it launches a Chrome store and asks them to install everything. Clever enough lure, it works. Maybe you want to do this as a post-exploitation thing. You get access to a user workstation, you want to install your extension for persistence. There's a couple different ways you can do this. My favorite one was doing this via the registry. So simply adding a registry key, all of a sudden the extension downloads into the browser. Like no user prompt, no user notification, like this, add this key, extension installs from the store. So pretty fantastic post-exploitation method, pretty easy to do. Note the 6-stub extender, like I got an extension in there for just to prove I could do it for 20 minutes, and then I deleted it. But this is a fully fledged extension that was in the store that used the exact same staging technique the bad guy was doing. So totally possible to get an extension in the store and use it for this purpose. So post-exploitation, this is really what I geek out on as a red team guy. We spent 90% of our team time doing post-exploitation stuff in in client environments, and so what exactly do I get by getting Chrome? Well, the simple answer is you basically get full control of the Chrome system. So that includes screen capture of Chrome tabs, key logging of the Chrome browser, hooking forms, so anytime anyone submits a form, you can gain an execution hook in there to access that data. Redirection, so if I want to intercept a request and change the route it goes. Social engineering, so the ability to pop messages, communicate with the user, give pretty images and techniques. And then browser pivoting, so if you're familiar with that concept, basically forcing a user's browser to browse where you would like under the context that they already have established. So walking through specifically the injection technique, so I told you I replicated the adversary's injection technique. I'm going to give tidbits of how this tool works. I have not released and will not be releasing this tool for open consumption, but there are enough pieces if you take a lot of pictures to get this going. So the picture here, this is essentially showing how I stage down a message into the application. So in this case, there's a JavaScript blob. It does a get JSON request to somewhere. I simply respond with a JSON blob, which is that picture in the bottom, message success. And then I end it with a dot replace and do this fancy evasion technique. Basically, I'm appending JavaScript that's obfuscated onto the JSON request or reply. That gives me execution of my rat. So we're going to walk through a bunch of examples. In this one, I'm going to hook form submission. So I have a Chrome extension calling back to my controller. I'm going to task my controller up through the API to start a form capture, specifically for that client ID. You're going to see my server said, cool, I understand what I'm doing. I'm going to come over to my Magic Facebook window. I'm going to log in with my 6dub.net account, which is not my real account. And then what you'll see here is that the browser that I form hooked captured that and sent those credentials back up to my controller for storage. So then I can go in and ask my controller to get the results of that tasking, and you can see I got the password. So basically hooked into the form extension using chrome.tabs.execute script, and got back the results and sent it up. Next cool one, key logging. This isn't really that special. JavaScript keyloggers have been around for years. Basically what I did here is leverage the ability to inject JavaScript in tabs to selectively inject a JavaScript keylogger into the tab. The key piece or fun piece about this is my JavaScript keylogger that I would inject used Chrome messages to communicate back to the extension. So like my JavaScript blob that was injected into the site did not communicate out directly. It communicated back to the extension, and the extension communicated out through the WebSocket that it already had. So no new tunnels standing up, no new communications, all using Chrome's messages, which allow tabs to communicate across. You can see essentially in here, I'll let it run through one more time, task to keylogger, typed in a cool sensitive message in the box. It was all logged using Chrome messages, exfiltrated out through the Chrome extension. I set the default to capture like 15 seconds of this tab, but all this is configurable depending on how much JavaScript kung fu you want to do. And in this case, I'm hooking Gmail, but you could really hook any site here that you wanted to, that you're able to get JavaScript injected into. This is my personal favorite. Every red teamer is a voyeur. Don't let them tell you otherwise. Like their whole job is to conduct espionage on companies and like use that for their advantage. And so in this case, I love screenshots. Like staring at text all day is fun, but staring at pictures is much more fun. In this case, you can use the Chrome API to do chrome.tabs.captureVisibleTab, which essentially allows you to capture a picture of whatever a tab is. Extensions can do this as long as they have the proper permission. And so I had my extension the ability to arbitrarily get screen captures of whatever web pages and then exfiltrate that out as a data blob through the normal WebSocket, store that server side, and then allow you to download and process that. So you can see here I had a user that was browsing the old ICEBRG website. I was able to get a screen capture of what they were browsing, in this case a picture of one of our researchers hard at work on his mechanical keyboard pounding away on some code. But screen capture, this could be anything from bank sites to your most sensitive health information that you're browsing, and your extension's rolling this all the time. Possibilities are endless. And then my personal favorite, anyone used like browser pivoting inside Cobalt Strike or Metasploit? Yeah, some, maybe an offensive person or two. The whole concept is if I issue a request in the concept of in the context of the browser, it's going to use whatever session information and cookies that the browser already has established. As long as the request is coming from the browser and the proper like cross-origin stuff's all okay. So if I can issue a request from the context of, I don't know, a Gmail tab, it'll have the session initiated and established from Gmail. Well, this extension can issue requests from any context that you have open. So if I can force my extension to log into Gmail from a Gmail tab you already have open and pull that request information back, I can see, essentially I can browse your Gmail inbox. I can pivot a request to Gmail through an already existing Gmail window and get the results and display it. So in this case, you can see here I task my thing to issue a Gmail mail.google.com request. And then what you'll see is I get the reply back, and I'm able to, I basically get the HTML back from my inbox. And then I'm able to kind of just grep through that HTML. In this case, I grep for like, I think secret password, because just proof of concept here, and I don't know. Who has password resets come to their email all the time? Yeah, like everybody. So it's kind of a proof of concept here, but I could browse to anything. I could browse to any CAC-enabled sites for govies, probably plenty in the room. Two-factor enabled sites, if you've got a session established, like they're able to be hit with this technique from an extension that you've installed. The last one, I had this concept of like, I want to gain code execution through an extension, because that's the ultimate sexiness. Like user installs extension, I get a shell, like how does that work? And so in this case, I kind of did a rigged proof of concept where I set up a vulnerable server, vulnerable to deserialization inside of a network, and I used the same exact browser pivot technique to issue a, basically a serialized exploit. So exploit throw in a serialized object into my request that's specifically crafted to take advantage of this vulnerability. And what you'll see here is I'm issuing this tasking. If I'm successful, I get code execution, I drop hi.text to the directory. So you can see in the top right there, a text file appears. That could have been a shell calling out or PowerShell running, or I don't know, C#'s the cool kid thing nowadays. So like maybe I, did .NET to JScript to get a C# module injected, or some technique. I get code execution on a vulnerable server sitting internal to a network, not public facing, all via a Chrome extension. So there's a leap in there that I'll leave unsaid, like how do I know it's there and how do I scan the network, but proved it out in the lab. It's very possible. So jumping into kind of the defensive side.
Yeah, so who here has heard of the Mitre attack framework?
Cool kids.
Awesome. Yeah, so we actually worked with them to get this added in as a couple of items here. So man in the browser, as Justin was just talking about, and browser extensions themselves as both a persistence mechanism and as a collection mechanism. The persistence part is pretty cool because not only with like the background permission set, but I mean your user is basically just going to start up Chrome every time they start their computer, so boom.
I would highly recommend if you're out discovering like new offensive tradecraft or you're a threat intel person finding stuff in the wild, like work with Mitre and get it added. You'll have the ability to affect hundreds of security programs versus just your own.
Right, because a lot of people go through this framework in validating like unit tests of like, these are, it's an attempt at like an exhaustive list of all of the bad things that someone can do to a system to, gain persistence or whatever, right? So people will go through this list and make sure that they're covered in all these different areas. So this is really, really important. It was a lot of fun working with the Mitre guys and getting this added. Okay, yeah, so where do extensions live on a system? 3 places. On Mac OS, it's there, Windows, Linux. So if you need to look for extensions doing weird stuff, those are the 3 places. That's it. Super simple. Really nice that it's not spiderwebbed all over across the computer. For network, just looking for an origin header being set. That's only for CORS requests though, or like requests that invoke like the cross-origin resource sharing stuff. So certain like GET requests won't actually trigger this. OS query. You guys familiar with OS query?
Some.
Okay, maybe, kind of. Okay, well, so it's basically just a way of, it's like kind of looking through like a system. It creates like kind of SQL tables of different configurations on your system. So you can do like a lot of different stuff. Like taking these over time is really cool. That way you can like kind of track changes to a system over time. And they've actually got a Chrome extension table defined in here, which is super cool. The persistent flag here, it's a little, I don't know, confusing in my opinion, because it's basically just specifying whether or not the background script is active at all times, which is not exactly the same as like the background permission, which I think would be more interesting. Yeah. Chrome extension, so Chrome actually, they have like this whole GPO thing that you can import with it. Yeah, 365 policies, a policy for every day of the year, of different policies that you can import into your Active Directory and get a lot of much more modular control over extensions. As far as like kind of, tightening stuff down security-wise, there's these extension install blacklist, whitelist, force list. So the force list will make sure that every system in your domain is forced to install this thing. And then whitelist are like what are good acceptable extensions for your enterprise, and then blacklist is of course, this is a known bad extension, let's blacklist that, I don't want that here. You can also do blacklist for all extensions. I don't want anyone installing stuff if you're really paranoid. And your users will see this type of thing. It's blocked by the admin. And so then they can go and bug IT to let them install it.
So I'm a former Intel guy, former red teamer and Intel guy. Like dual personality some days. We had this concept in the military called getting left to boom. It was for counterterrorism purposes. The idea was like we want to get ahead of when bombs are detonating, so we want to know about something before they're happening for the purpose of issuing early warning and prediction and stopping it. A lot of what I do on the Gigamon side is similar. So I'm a threat intel dude here. Everyone probably has strong opinions about threat intelligence depending on how your organization implements it and does it. There's different levels, strategic to tactical to functional and all these things. In my opinion, threat intelligence's key role is to inform decision makers and then prioritize and support defensive efforts across the entire spectrum. So that kind of includes 3 key areas. I'm doing everything I can to support responders and inform them and enrich them with more information about what they're responding to. I'm informing detection efforts, so maybe I have a SOC or detection team. My goal is to like make them understand how threats really work. So that's the point of boom. I'm supplementing that point of boom by helping them boom on more things and boom more intelligently. And on the left-hand side, which is what we're going to talk a little bit about now, is early warning. I want to discover things before they ever affect my organization. So you might be wondering how you do this with Chrome extensions if you're a threat intel person. Well, if only there was a data source that was constantly crawling and categorizing every Chrome extension for the past couple years. There exists such a resource. It's not ours by any means. We don't run it. Use it your own warning and disposal with all the normal legal disclaimers. They're crawling Chrome. But it's a fantastic data set to look at, and it proves to be very useful if you want to go get access to bulk Chrome information. So what kind of things can we do in a like generic hunty, like I want to discover things before they're known bad? We can kind of genericize some of the things we're looking for. So rather than just looking for specific variable names to our campaign we are tracking, let's just look at suspicious variable names. So what makes a variable name suspicious? I don't know, like random hex. Because variable names shouldn't be named random hex, they're for humans. And so that's the kind of the one on the left. The top right is kind of the JavaScript keylogger functions that are commonly used. So if they're not obfuscated, looking for the key codes or key press function. Extensions should not be logging key presses very often. So this tends to be a slightly better confidence one. And the bottom right, looking for extensions kind of setting cookies and storing information that might be useful for configuration. Examples of what we found using these, so like these 3 rules, that baby's face is like what I constantly had looking at stuff like this. The left one is all the hex variable names. Again, all 3 of these, like I'm not 100% sure they're evil, but they don't look normal. Like this isn't what I normally see when I'm installing my browser. So a whole bunch of hex, obviously obfuscated Chrome code. The middle one, you have .NET DLLs in your Chrome extension. Like, don't know why Chrome, like an inherently static web page Chrome extension, should have all these C# .NET mono libraries all loaded up inside of it. And the right one, you see every file is just named with like a single character. Looks like they tried to do some sort of smash and grab on the file names like obfuscation. So again, we can kind of hunt and start going through these. We can work with Chrome to notify, or if you're an Intel organization, you can protect your customers by adding another touch point of finding evil and stopping it before it affects them. So getting to the wrap-up point a little bit early, but some things I really want you to take away. So stepping back to a larger view, Chrome extensions are just one example of potentially unwanted applications or software. It's not specifically some APT threat, depending on who's using it. It's just generically, maybe it's not wanted. The admin doesn't want that level of ability. And in general, I've seen kind of a couple different strategies with PUA, or potentially unwanted applications. One is people will try to educate the users, or like, I don't want to lock down my users, I'm just going to make them experts in computer security so they never get our organization owned. I think most people in the room can see the issue with that and have probably dealt with some issues with that. It's possible to an extent, but users going to use. It's Matt Nelson, used to work with, always said this, like simply not going to prevent users from doing something like this. So you need a combination. That's what brings in the second viewpoint, which is control the users. Some people go overboard with this. It's like, I want to lock down everything. They can never do anything without calling me. And then they get to answer phone calls at 2 in the morning all the time for things that maybe they should have just let in the first place. So you can see I kind of have the perspective that it should be a mix of both. Like there should be some amount of technical controls. You can do a good analysis of what your organization and your company actually require and what your users require. Allow that, and then prevent the rest. I'm pretty big whitelisting fan across all of the security spectrum. I understand it's hard. Chrome makes it pretty easy with the GPOs as long as you can enumerate what your organization needs and you're willing to suffer for the first couple of months you roll out the policy as you discover more things. So So what's next? This research it still has a lot of unanswered pieces, and we're not going to go Chrome the rest of our lives. So love anyone who is interested in this stuff to get going. Download the archive, play with it, go hunting. Some key areas we were really interested in is other browsers. So as they roll out that web extension API, can these same like Chrome rat you develop in Chrome work on Edge or IE or any of these other Firefox or these other places? Is there a common API that can be implemented? Essentially getting a cross-platform rat in the browser. It'd be very useful, it'd be very interesting. Continued in monitoring of this. This campaign's still going, we're still tracking and working with Google on this. It's kind of hard to get ahead of these guys. They evolve like every adversary, and so it takes a lot of close monitoring. As you find stuff, set up monitoring, go look for it, see if they evolve, see if they adapt. It can be really useful both for yourself and the organization, but also as a research perspective, very interesting to see. And then there's plenty of work to do. We found all sorts of malicious stuff in the store. Code execution methods, I'd be particularly interesting if we can get more system code execution techniques or easier ways. Going beyond the browser, how can I get from extension land into system land? I'd imagine there's probably tons of ways. I'd never opened a debugger during any of this. Like this was all very simple, like surface level research. There could potentially be a ton of different avenues here that aren't looked at because people, frankly, aren't looking at Chrome extensions from a pure security perspective very often. And then, again, continued bad guy tracking. That's like a double foot stomp. Like, bad guys are there. Like, we should keep watching them. So I have a little bit of time for questions if there's any in the room. One in the back left.
You mentioned the other browsers are adopting the API.
Yeah.
The GPOs, just to save myself some time, are those browser agnostic or are those only for Chrome?
So the question was, we mentioned that the other browsers are adopting the web extension API. Is the GPO cross-browser or is that just for Chrome?
Pretty sure that's just released by Google for Chrome specifically. Chrome for Enterprise GPOs. I'm not sure if the other browsers have something like that. I'm sure Microsoft might have stuff set up for Edge and stuff. I'm not actually sure. Yeah, have to verify that. But I don't know if anything that Mozilla is doing or any of the other major players in the browser field.
Any difference in behavior between Chrome, like user level or Chrome Enterprise?
The question was, any difference in behavior between Chrome user level and Chrome Enterprise? I didn't see any.
Yeah, no, I think those pretty much operate the same. Like it's still the same browser. It just has certain kind of hooks. Yeah, kind of so that it allows your domain to kind of mess with it.
More touch points for admins, honestly, I think are really only thing we observed.
Yeah.
Oh, middle.
Yeah, given the kind of user interaction needs to install some of these extensions, are there any coordinated disclosure concerns, or should you just really kind of blast out whatever you find to get it to as many people as possible?
So the question was, given the amount of users installing these extensions, is there any disclosure concerns as far as like releasing what we discovered in terms here?
Or before you tell Google, I mean, or you just...
Yeah, absolutely. I would say absolutely. We coordinated all this for Google. We've been doing this for almost a year and a half now. Many of the ones that we listed and showed here are way, way old. I personally feel there are. I mean, you've got an affected user pool that's very large. I think that it would be good due diligence to share with Google to get it taken down before releasing open research. It's purely my opinion, as I stand wearing a Gigamon shirt. But I think, in general, I like to work with the vendors and solve the real problem before going out and sharing it.
Right, responsible disclosure and all that. We've worked with Google and stuff before we release our blogs just to make sure that everything's cool, and then we're like, hey, look at this cool stuff we did.
I'd also add that we've taken a step further and we've like volunteered and tried to work with them to do more like general work. Like here's what we're doing to discover these, and like here's our Yara SIGs, and we're trying to encourage them and help them along the path of finding just generic things. They don't usually need our help; they're experts on Google, but we like to offer it. It's good. Like we've done the research, might as well share. Sure.
Was there any commonality as far as like the domain registration or basically like hosting providers used for CTF?
So the question was there any commonality between the domain registration and hosting providers use?
Yes.
Yes.
Short answer, yeah.
The domain registration, I believe, is all privacy protected. Am I correct?
Yeah.
But
yeah, it's all who is
the same hosting provider, same ASN, and it was all in the same Class C net block. So like, we've shared these indicators on a blog. If you want to go, like, you can go look at the Class C net block. It's pretty prevalent there. They actually had an infrastructure that was like up to, at one point, 30 or 40 like C2 servers. It's pretty massive infrastructure for a single campaign in a Chrome extension. So you can, it's kind of scale of operations, like it makes sense that they're doing this on a larger scale. And they're pretty much all there. And we've done all the notifications, all the different routes you can notify people about all these things.
One thing missing is actually all of the C2 servers were, they're Serverl, which is like a hosting provider, so shared hosting, but they do hosting in various locations around the world. All the C2 was in the Netherlands, interestingly enough. I assume that's because they thought that's a better place to host things, just legally.
Analytic assumption.
Yeah, I mean, no, yeah.
No fault on the Netherlands.
Yeah, we'll see, I don't know, but.
Awesome. I think we'll wrap it up then. If you guys want to talk, we'll be in the back or around the lobby. Thank you guys for your time.